Okay, remember the first thing that we need to do is make sure that our name is on our paper. Okay, so we're dealing with an unknown trait here. A mysterious new trait or genetic disorder is the title of this first section over in the top left. Traits can be inherited in several different patterns. We've seen some of those patterns already. When doctors and scientists are studying a new genetic trait in a family, they try to figure out how the trait is inherited. In order to do that, they look at a pedigree for clues. So like I said, we've seen some of these patterns of inheritance already, but let's review so that we know what we're dealing with. Okay, so I've highlighted this section together so that we can see that all 6 of these boxes are relating to possible modes of inheritance. So one potential mode of inheritance is autosomal recessive. So an autosomal recessive inherited trait would be caused by a recessive allele on an autosome. So remember, a recessive allele would be the lowercase letter, and an autosomal recessive trait would mean that both a male or a female would need 2 copies of the little letter in order to have the trait. An autosomal dominant inheritance pattern, the trait is caused by a dominant allele. On an autosome. So in this case, for both a male and a female, they would only need 1 copy of that allele, because it would be the big letter, the capital letter, in order to exhibit the trait. So I highlighted those together just to show you that males and females would inherit that trait in the same manner. An X-linked trait, we have 2 different types here. So an X-linked dominant inheritance pattern, the trait is caused by a dominant allele on the X chromosome. Now, in this case, both a male and a female would only need 1 copy of the dominant allele in order to exhibit the trait. That being said, the female, if she were heterozygous, so she had 1 of the big alleles and 1 of the small alleles, she could pass on the recessive allele to her offspring, to her female offspring. A male who had the disorder, since he only has one X chromosome, he would pass on the disorder to all of his female children. And then in X-linked recessive inheritance, the trait is caused by a recessive allele on the X chromosome. So this is what we talked about in the X-linked inheritance notes. And in this case, a male would only need one copy of this allele to exhibit the trait because he only has one X chromosome, whereas a female would have to have two copies of this allele in order to demonstrate the trait, because if she has one copy of the dominant allele, she's not going to show the trait for the recessive allele. Okay, Y-linked inheritance, the trait is found almost exclusively in males because it's found on the Y chromosome. And females, biological females, do not have a Y chromosome. And then there's mitochondrial inheritance. So we talked a little bit about mitochondrial inheritance when we were learning about cells and DNA. Remember, your mitochondria has its own DNA, and that is inherited from your biological mother, regardless of whether you are male or female. The mitochondrial DNA is inherited from your biological mother. And is caused by a mutation allele in the mitochondrial DNA gene. So remember, we talked about how there has been one child, the child is not named, but there has been at least one child born with quote unquote 3 parents, because the mitochondria in the egg cell was from a third donor. And it was done that way because the biological mother, who provided the rest of the egg cell, had faulty mitochondria. So they didn't want to pass on the faulty mitochondrial DNA. Okay, so now let's go through this problem. A set of parents, II3 and II4. So let's identify who these parents are. So II3 and II4, because II and 3 and 4. So these are the parents that we're dealing with. They came to a genetic counselor, so they came to a doctor and a genetic counselor after becoming concerned with a rare blood disorder that 3 of their sons have. The mother, II3, remember that's a circle. Remember, let's make ourselves a note. Circle is female. Square is male. And then we look at the key and we see that filled in means that they are affected by the blood disorder. So 3 of their sons, you can see in the III generation, you see 3 sons that are affected. 1 son is not affected, and the daughter is not affected. The mother, II3, tells the doctor that her father, I1, also suffered from a similar blood disorder. What is the most likely mode of inheritance for this blood disorder? Now, it says a similar blood disorder. It may possibly be the exact same disorder, but remember, genetic counselors are dealing with the information that's provided to them by patients, and patients are not always the most reliable at conveying information. So we go with what information we have. So let's look at our pedigree and let's see what we can figure out. So the first clue is that person 1 has 3 children. I1, has 3 children. So 1, 2, 3 children. Okay, because remember, this is the child line. How many of those children have the disorder? Well, are any of those 3 shapes filled in? No, none of them are filled in. So none of them are affected. But his daughter II3 has affected children. So how could she have affected children if she does not have the disorder herself? That's right, it would be recessive. I1 is male, and all of his affected grandchildren are male. Now, he does have an unaffected male grandchild, but if we look at who is affected, we see in this pedigree that only males are affected. So, it doesn't guarantee it, because there is probability in genetics. You have 2 copies of a gene, so it's a 50-50 chance what you pass on. But the fact that I1 is an affected male, and the only people affected in the III generation, the only people affected at all in this pedigree are males, it suggests that the blood disorder allele is found on the X chromosome. Now remember, X chromosome is the female chromosome in a way. Everyone has at least one X chromosome, but XX is female, XY is male. But remember why it would make sense that males would be most affected by something on the X chromosome. And it's because males only have one X chromosome. So if they get one copy of the defective gene, they will have the disorder. Females, if it's a recessive X-linked trait, have to have 2 copies of the recessive gene in order to demonstrate the trait. So this suggests that the blood disorder allele is found on his X chromosome, which was passed to his daughter. So remember, he had an X chromosome and a Y chromosome. He passed on his X to his daughter. And then, and actually, let's go ahead and put specifically who the daughter is. So they are Roman numerals, but you just type them as capital I's. So his daughter, II3. Now, she has 2 X chromosomes. see if these are enough different that you could see this pattern. So I used a different pink for the different X's in regards to the male at I1 and the female at I2. I used the same pink for both of her X chromosomes because it seems unlikely that the faulty allele is on either of her X chromosomes. So we know that he passed his Y to this person. And that person got the X from the mother. So II1 would have the allele from the father that has the faulty gene on it. She just doesn't have any kids. Okay, in the III generation, we know that individuals III 2, 3, and 5 are affected, which means they would have the faulty allele. So they got that X chromosome. And then they got a Y chromosome from their father. III4 does not have the disorder. So he got the good X chromosome from his mother. And then he got the Y chromosome from his father. For the female in the III generation, we really don't know which X chromosome she inherited from her mother. We know that she got one X chromosome from her father, but she doesn't have any children of her own, so we don't know whether she has the faulty allele or not. But the ones that I have filled in, we do know for sure the way in which it appears to be inherited throughout the generations. Okay, so this suggests that the blood disorder allele is found on his X chromosome, which was passed to his daughter, and then passed to 3 of his grandsons. Who are in the III generation. So the blood disorder is most likely due to a recessive allele on the X chromosome. Based on the information we have on the pedigree above, it appears that this is a recessive allele on the X chromosome.